everyone. My name is Sanders Kleinfeld, and it's my pleasure to welcome Ferris Jabr to Talks at Google today. Ferris Jabr is a contributing writer for the New York Times Magazine and Scientific American, and has written for a variety of other publications, including National Geographic, The New Yorker, The Atlantic, Harper's, Wired, and Foreign Policy. He has received a Whiting Foundation Creative Nonfiction grant, as well as fellowships from UC Berkeley and the MIT Knight Science Journalism Program. His work has been anthologized in the 2014, 2020, and 2023 editions of Best American Science and Nature Writing. Ferris is here today to discuss his new book, Becoming Earth: How Our Planet Came to Life, in which he narrates his experiences exploring the mysteries of Earth's ecosystems with the research scientists who study them, traveling 4,850 feet into the Earth's crust, scuba diving into the underwater forests off the coast of California, and scaling a tower 1,066 feet into the sky above the Amazon rainforest, to explore the interconnected life forms and systems that compose our living Earth. Thanks so much for joining us, Ferris.
Thank you so much for having me. Pleasure to be here.
Yeah, I'm so excited to talk to you. So to kick things off, something that really struck me while I was reading your book was how much of our contemporary discourse uses language that really separates out humanity from the rest of the world in which we live. So we talk about how our actions are harming the world's ecosystems, without really considering or reckoning how we ourselves are not just dependent on those ecosystems, but like are actually constitutive of those ecosystems. And I was wondering if you could talk a little bit more about that.
Yeah, I think that's part of an even larger historical pattern where, Western science has really segregated geology from biology and the animate from the inanimate. Historically, we've been, sort of taught to think of Earth as basically this giant rock, which happens to have some life on it. It would happen to be in the right place in the cosmos that life could evolve, and now there's some life on its surface. Historically, science has also minimized the role, the importance of life shaping the planet. And now we're seeing a pretty big shift happening within the world of science. The new recognition is to be aware of just how profoundly life continually transforms its environment, including the entire planetary environment. And to see life as continuous with Earth. There is a material, literal continuity there. I've come to see life not as something that simply inhabits or resides on the planet, but that is, a literal expression of the planet. It's an outgrowth of the planet's structure. Life is made of Earth. It profoundly shapes the planet all the time. And so, this notion that we as humans are somehow exceptions, that we are somehow separate from the rest of nature, from the various systems we're embedded in, just not only, it just doesn't hold up at all, given everything that we know now, especially with, 21st century ecology. And it's true for all life, really. All life is continuous with the planet. And is really, I've come to think of it as synonymous with the planet. Everything we call life is really Earth, is really made of Earth and is part of the Earth. And that is very much true for us as well. So we have to stop pretending like we are somehow separate from that, that we can somehow get away with not being part of these greater ecological living systems.
Yeah, I know you talk a lot about the Gaia Hypothesis in the book and how we should really think of, Earth either maybe literally, but if not definitely metaphorically, as a sort of super organism. So that like life exists at the microscopic level and the macroscopic level and at the Earth system level.
Right. Yeah. So, the Gaia Hypothesis was first proposed between the 1960s and 80s by British scientist James Lovelock, and then later refined with American biologist Lynn Margulis. And they were saying, wherever life emerges, it will inevitably transform its home planet, and that together life and the larger planetary environment, they form a single system, a single living, self-regulating system. And this is very comparable to an organism. They were trying to draw these analogies and metaphors between the planet and smaller life forms. And sometimes Lovelock would get a little cavalier about this. He would literally state that Earth is an organism or is a superorganism. And other times he would say that no, he was just saying that as an analogy. I think that, we have to, like you were saying, recognize that life is this multi-scalar phenomenon. So, for example, the cells that compose our bodies, they're not organisms in and of themselves, but everybody agrees that they are alive. And then you have, the level of the organism, and then there's the level of the population or ecosystem, and then going even a step further, the level of the planet. I think at every one of those levels, we see the phenomenon we call life emerging. And I don't think it makes sense to restrict it to the level of just the cell or the organism. I think it can happen, at even smaller scales, like molecular scales or viral scales, and then larger ones as well, like ecosystems and planets. And so to say Earth is alive does not necessarily mean you're saying that Earth is an organism, exactly the same way that a bird or a bacterium or a human is an organism shaped by natural selection. Earth is different from that. To me, it's more like a massive ecosystem. It's more like the Amazon rainforest or something. It's this vast, interconnected living system with many components, some of which are animate, some of which are inanimate. But the system as a whole demonstrates many of the fundamental features of life, including features that we see in smaller constituent life forms like organisms. And that's what I think is really important, is that, these same types of features, characteristics, relationships, capabilities can emerge at multiple scales and levels, not just the scale of the organism shaped by natural selection.
Yeah, I think one thing specifically that really struck me as well is that the line between inanimate and animate, and or not alive and alive, is a bit more blurry than I thought. I mean, you tend to think of that as like, this table's not alive, I'm alive, or whatever. But like, one fun fact that you share in the book that I didn't really realize is like snow contains microbes potentially. So where do you draw that line? It feels way more blurry than I originally thought. So.
Yeah, absolutely. I think there's, growing recognition in science over time that life is much more of a spectrum than a strict category, and it's very difficult to precisely delineate the living from the non-living. And, I'm fascinated by how we think about life in everyday conversation and how we use the terms living and non-living. And as you point out, there's many fascinating, complicating examples that make it very difficult to lump all the matter in the universe neatly into life or non-life. Fire, for example, it consumes fuel. It's basically eating, and then it's growing as it's doing that. Crystals have these incredibly complex, very organized structures that they replicate and grow. I mean, you can grow crystals in a bucket at home if you want to, but we don't think of crystals or fire as alive, even though they're doing things that we associate with life. And then conversely, there's examples of living organisms that will enter these periods of what is basically death, this extreme dormancy where they're not growing or metabolizing or eating or doing anything. And yet we still think of them as living entities because they can revive themselves. So to me, that shows us that life is really this active phenomenon. It's a process, it's a verb, not just a noun. It's not a type, it's not a special type of matter or a specific property of matter. It's really a thing matter does, right? It's a process matter can participate in. And I think we have to be open to the idea that any system of matter that has sufficient complexity and has available energy can participate in that phenomenon, whether it's carbon-based or silicon-based, whether it's something that we recognize here on our planet or something we might find somewhere else in the cosmos that doesn't look anything like what we have here. And so, yeah, I think there's, continually this rethinking of what life is and a broadening of the concept of life and really trying to figure out what is life at the most basic physical fundamental level. And, that's much of what the book and the history of all the science is engaged in.
Yeah, so I wanted to talk more about some of the explorations that you undertook in the book. Were there any that you found particularly illuminating or transformative in this sort of philosophical discussion that we're just having? Anything that stood out in your adventures?
Yeah, I got to go on some really amazing reporting trips for this book. It was a real privilege to go with scientists into these really fascinating ecosystems around the world and some really extreme places. In South Dakota, there is a former gold mine called the Homestake Gold Mine that's been converted into a subterranean scientific laboratory. And you can descend close to a mile beneath the surface of the planet in this former gold mine. Most of the scientists that go there are physicists conducting these really specialized experiments that they have to shield from cosmic rays. So they use the mile of rock surrounding them to do so. I went with geomicrobiologists. So these are microbiologists that study how microbes are involved with the planet's geological processes. Microbes, we now know they're inhabiting the deep crust of the planet, up to like 2 miles beneath the surface. They live in these tiny pores and fissures filled with water. They get energy from radioactive reactions, and from rock and metal itself. And we also know that there's microbes really high above us in the clouds. They get whisked into the atmosphere, they change the weather, they stimulate rain and snow, and they fall back to the surface. And I got to climb this tower in the heart of the Amazon rainforest. It's actually the tallest structure in all of South America. And scientists visit that tower to sample particles and gases from the atmosphere, at various levels above the Amazon rainforest, partly to study how the Amazon makes its own rain and just the relationship between the forest, the soil, and the atmosphere. Climbing that tower was pretty intimidating because it doesn't really have any sort of safety barrier. It's basically just a very bare bones scaffolding kind of utility like tower. So you have to be harnessed to a railing as you're climbing up, and you can still fall through the gaps. But once you make it to the top, you get to see the rainforest from more than 1,000 feet in the air. And you just see this massive living network stretching to the horizon much further than you can even see into the distance. And you really feel the forest as this, tight-knit living fabric. You can really see it at the systemic level. Whereas when you're on the ground, you're just overwhelmed by the density of life around you. You're chasing this butterfly or examining this like tiny piece of lichen or something. So it's a completely different perspective. And by the time I got there, I was starting to really understand how much of the planet is shaped by life, or made by life in some ways. And so I could see that the clouds above us and the rain that was going to come from them and the soil below, and so much of the chemistry and the structure and the geology of the planet was all a product of life or influenced by life. And I was able to sort of visually see a visual manifestation of that from that perspective in a way I hadn't been able to before.
Yeah, just reading about it, I found the discussions, which you alluded to earlier, about how the rainforest generates its own rain to be incredibly fascinating, because I think we sort of think of the weather as being independent, getting back to what I was saying earlier, from actual life, that we're just sort of subjected to the weather. Can you talk a little bit more about how the rainforest generates its own rain?
Yeah, this really was the seed of the whole book for me. Like more than 10 years ago, I learned this astonishing fact that the Amazon rainforest doesn't just receive the rain on which it depends, it generates about half of the rain that falls on its canopy each year. And the way this happens is so fascinating because it's more than just trees and plants pulling water from the soil and releasing what they don't need to the atmosphere. In addition to doing that, they're also continually spewing these invisible plumes of tiny biological particles that are called bioaerosols. So these would be things like pollen grains, microbes, fungal spores, little bits and pieces of leaves, even little pieces of insect shells. All of these tiny biological particles get swept high into the atmosphere, and they give something for all that water vapor released by the forest to condense onto. And that's how clouds form. Clouds form when water vapor condenses onto suspended particles in the atmosphere. And in places like the Amazon, and indeed wherever there is dense life, biological particles are the most important seeds for clouds in the atmosphere, not inert, inanimate particles like dust and soot. So, then some of these particles even seed ice crystals within the clouds. So, as you were mentioning, there's a particular bacterium, Pseudomonas syringae, and it has extremely effective ice nucleators on its cell surface. So these are proteins that can arrange free-flowing water molecules into a solid frozen crystal. So that microbe and other particles encourage water to freeze within clouds, clouds that makes them heavier and larger and more likely to burst and fall as rain. And in fact, most of the rain that falls on land, even in tropical regions, begins as ice crystals and clouds and then melts on the way down. So, microbes and other biological entities and biological detritus is hugely important for the water cycle, not just above the Amazon, but really around the world. So life really is creating the weather all the time, not just receiving or experiencing the weather.
Yeah, I think there was a stat in there in the book. I'm going to horribly misquote it, just about how impactful the rainforest is. I believe it affects weather all the way extending up into the Pacific Northwest and basically all throughout the Americas.
Exactly. So through these incredible, so first of all, this like massive flying river the Amazon generates, it actually travels throughout the continent of South America, and it brings precipitation to other parts of the continent that would dry out otherwise. And then through these long range atmospheric ripple effects, the Amazon is also influencing weather in North America as well. So it's changing the weather in Canada. And some scientists have calculated that, if there was enough deforestation and the Amazon's rain cycle broke, that would actually massively reduce the amount of rain in California's Central Valley as well, which would then have horrible repercussions, for the entire agricultural economy of the United States. So it really is an amazing demonstration of the interconnections of our planet's different ecosystems, and how, a tree growing over here can have a huge influence on the weather way over there.
Yeah, and I think that sort of brings us to like basically the elephant in the room here when we have all these sort of kind of conversations, which is about like human-driven climate change and how we are disrupting these systems right now and what's happening as a result of it. So one anecdote that really struck me in the book when you're talking about all the plastic, for example, that's washing up on the shores of the beaches in Hawaii. I didn't realize how deep that impact was, not just on a plastic bag floating in the water or whatever, but actually like transforming land masses on Earth and the ways that it's really just reshaping ecosystems. I think the term you said scientists coined for that was plastic glomerate.
Right. So I visited Camilo Beach on Hawaii, and this beach has become particularly infamous historically for accumulating huge amounts of plastic waste. The Hawaiian Islands kind of act like a massive comb or strainer in the middle of the Pacific. Because they're in the center of these gyres, the currents just kind of continually sweep all this debris into the islands, and the string of them kind of collects it all. So huge masses of trash would accumulate on this beach. In the past, they would be 8 to 10 feet high, just massive piles of plastic waste from all over the world. Thankfully, now due to cleanup efforts, the plastic is massively reduced, but there's still innumerable tiny particles buried in the sand. And if we do not continually clean the beach, it will accumulate once again to that massive level as it was before. On this beach, geologists made an incredible discovery, plastiglomerate. It's the first rock type in the planet's history that is partly composed of plastic. What seems to be happening is that Camilo is a place where the human and non-human, the animate and inanimate, the geological and biological all get smashed together. And people routinely make campfires on the beach. And because the whole beach is just steeped in plastic, it's impossible not to melt and burn plastic when you do that. And then some of that melted plastic fuses with sand and shell and rock on the beach and forms a new compound material that scientists have dubbed plastiglomerate. It's an incredibly durable, resilient material. And potentially plastic objects can actually fossilize and remain in both the rock record and the fossil record for many millions of years. So millions of years now, if there are still human archaeologists or alien ones, they might dig up, some plasticized fossils, and that might be sort of the signature of our time on this planet. And plastic really warps, the whole planetary ecosystem in very fascinating and also kind of horrifying ways, because you see, plastic is made of petroleum, and petroleum is largely made of the ancient remains of plankton that have been sequestered and cooked and compressed deep within the planet's crust. And that's really what fossil fuels are. There are these stores of ancient life that have been cooked within the planet's crust. Then we go in and unbury them and use them for energy. So we take these ancient plankton, we turn it into plastic, then we pollute the ocean with plastic, and it breaks down into innumerable particles that then start to mimic real plankton in very bizarre ways. So predators start to eat these tiny plastic particles because they look and smell like their prey. And then these plastic particles start to drift to the sea floor and collect in seafloor sediments the way that real plankton do. And this is warping the ocean carbon ecosystem in ways we don't understand. And so I've come to think of plastic as a kind of chemical necromancy. We've revived ancient plankton and then discarded them in the ocean, where they start to mimic real plankton. And so plastic is kind of this necromancy and this ecological imposter in the ocean ecosystem. And we don't think about that. You're right. We don't think when we just use a plastic bag at the grocery store that it's going to have an effect on the Earth system in over millions of years. But that is truly what these materials can do.
Yeah, and on top of all that, I believe that you were also discussing just the impact on the environment of creating the plastic in the first place. So the fossil fuels burned to create these plastic, polymer substances. And I was wondering if you could talk a little bit more just about impact of carbon emissions. And also in the book, you also discuss a lot of really promising experiments about how we can counteract some of those effects and draw carbon out of the atmosphere.
Right. So, the current planetary crisis, anthropogenic climate change, is really, at its most fundamental level, a massive perturbation of Earth's long-term carbon cycle. So, Earth and life have co-evolved these ways to sequester carbon deep within the planet. And the amount of carbon stored in different parts of the planet has a massive influence on global climate. When there's a lot of carbon in the atmosphere, the planet tends to heat up. And when there's a lot sequestered below, it tends to cool down. And what we're doing right now is unearthing huge stores of carbon and releasing them to the atmosphere. So that's heating up the planet. And, probably the two biggest ways we're doing this is by unearthing fossil fuels and burning them, but also through agriculture and land use change. So any ways in which we destroy ecosystems and use the planet's land surfaces to grow crops or raise livestock or build infrastructure, that is also releasing huge amounts of carbon to the atmosphere and disrupting the living systems that store carbon. So those are kind of like, the two huge areas where we really have to focus our efforts, is reforming energy infrastructure and modern industrial agriculture, so that they are compatible with a sustainable world, and maintaining a habitable and living planet. And so, of course, some of the necessary interventions are ones that we've known about for a very long time. The knowledge base is there, the technology is there. Switching to renewable energy and clean energy, and reforming modern agriculture so that it really uses a lot less space and really treats the soil as an incredible living resource, and that we really, prioritize sort of energy dense, high nutrient crops that have the least ecological impact. So things like legumes, a lot more legumes, and grains, and not so much meats and crops to feed animals. And then in addition to that, the kind of science I explore in the book really underscores a complementary approach, which is to emulate, recognize, appreciate, emulate, and conserve the planet's systems that are already innately self-stabilizing and climate stabilizing and carbon sequestering. And really the best way to do that is to conserve and restore ecosystems that are already doing these processes on their own. So these would be things like forests, grasslands, so-called blue carbon, all the amazing aquatic vegetation on our planet, wetlands, peatlands. There are all these incredible incredible ecosystems that are already storing immense amounts of carbon. Simply by pulling back and not destroying them, that would already be a huge turn for the better. And then we can also try to restore, what we've damaged through various conservation efforts, through rewilding, through all kinds of amazing programs. I think together these approaches, for me, kind of form the central goals of our new relationship with the planet going forward. And we are making progress in places here and there. The problem really is speed and scale. We're not moving nearly quickly enough to address the rapidity of the crisis itself. And we're not acting at the scale that we need to be quite yet. And so, every moment that we delay in achieving that necessary speed and scale makes things all the worse. It's not too late to preserve a habitable planet, but at the same time, every moment that we do not act with the necessary speed and scale, we just commit ourselves to an even worse future than we had the moment before. So it really is this emergency, even though it's hard sometimes to feel that viscerally or palpably, from moment to moment. And so, there are so many amazing people on this planet that have already dedicated themselves to this cause and to trying to figure this out and manage it. And I think we have seen significant social and political change in recent decades, and we just need a heck of a lot more of that to really guarantee a livable world for ourselves.
Definitely. I think one thing that always comes up in my mind whenever these discussions come up is just thinking, like, what as an individual can I do to help, create positive impact in counteracting and mitigating some of these issues. So I'd love to hear your thoughts on that. In particular, I was really captivated by your description in the book of how you went about building a new backyard garden in your home. In an area in which the conditions were not really conducive to doing so. For those things, I'd love to hear more about how you went about that.
Absolutely. Yeah, the garden really became the way in which I was most personally and directly engaging with this material and really changing my individual relationship with the planet. So my partner Ryan and I bought this house in Portland, Oregon a few years ago, and there was nothing here except for a derelict grass lawn. We knew we wanted to create a garden from scratch, and we had all these wonderful plans to do so. We were going to plant all these lush, long blooming perennials everywhere. And then I quickly discovered that the soil on our property was in really bad shape. I mean, it was full of rubble, it was clay heavy, it was unyielding. This whole area had apparently been a construction site and a parking lot for a long time, so it was in very, very bad shape, really neglected. And so I entered a period of intensive study where I tried to really learn about soil science and how to, bring our soil back to a healthy state, basically. And that one chapter in the book really focuses on, the current state of soil science, the history and future of our soils, and this growing recognition that we can recognize soil not just as a medium or a substrate for life, but really as a living entity in and of itself, this incredible living network of rock, air, water, and creature. And so coming to that new understanding of soil really helped me understand how to bring our soil back to life. And I started to apply a lot of the principles of, regenerative agriculture to our personal backyard. So we put in drip irrigation to reduce soil erosion. We started composting and mulching. We allow plants to decay in place to return their nutrients to the soil. And we covered the entire landscape with a huge variety of healthy plants. So their roots permeate the soil. They help aerate it. They bring in the ecological communities of microbes and fungi that are necessary for soil health. And they cloak the whole soil surface with their vegetation, preserving the soil's architecture and essential structure. And so slowly over the past few years, we've seen our soil turn from obdurate and unyielding to much softer and looser and richer. We now, where once there was just grass, turf grass, we now have a wildflower meadow, a wildlife pond, raised beds for vegetables, a rockery, drought-tolerant perennials, and all kinds of birds and insect and wildlife, and even mammals like raccoons and mice, and have all come to the garden because of these new resources. So it's been a real joy to see that personal transformation of this, this tiny portion of our living planet that we have some sway over.
That's incredible. We're almost at time. Related to that, I'm just wondering if you have any advice for folks as a takeaway of what they can do to help mitigate the problem of climate change. Like at an individual level, if there are particular modifications that they can make that would be particularly impactful in this effort.
I believe everybody should try to find the intersection of, their talents and skills, their interests and passions, and then what kind of the world needs from all of us right now. And that can be so different for different people. For me, it was writing this book. This was really the best way that I'm able to engage with the current planetary crisis and make some small contribution towards managing it. For other people, it might be learning how to be a so-called firelighter and to use prescribed burns or controlled burns on the landscape to help combat the wildfire crisis. It could be political activism. It could be working for food sovereignty or a food bank. It could be building a native butterfly garden or native pollinator garden. So many different ways that different people can do this. So I really think that that is to me a more inspiring way to think about it than sort of the finger wagging, like, oh, you have to reduce your carbon footprint or whatever kind of approach. Like find what you love and what you're good at that is also contributing to this necessary reform in some way, and just go for that. That's really the best advice I have.
Thank you. I think that's such great advice. And thank you also for this incredibly enlightening and really important discussion. To everyone watching, please go and pick up Ferris's new book, Becoming Earth, and learn even more about this topic. Thank you so much for joining us.
Thank you. Thank you for having me.